All right, everyone, we'll get going. This will be our fourth session now. I'm going to talk about Use Case 7, which is a new kind of testing program that I've slowly developed over years and have found to be very helpful in product development programs. So Use Case 7, there's a reason why it's showing a beat up sign there, because I'm going to show you how it's a testing method that can be done that uses very high stresses, but it's different than Nehalt and it's different than stress margin testing. So I think the most important place to start is with the definition of reliability. And it's the probability that an item will perform its intended function under stated conditions for either a specified interval or over its useful life. So these are all very important parts, the three most important being intended function, stated conditions, and the interval. But you can see I've highlighted two of them. I highlighted intended function and stated conditions. And this is what the Use Case 7 methodology looks to address and to create improvement for the product. So, as product development engineers, you know that our customers use our products in some very imaginative ways, right? And you have to still try to address it, see if it's going to become input to the design, or if it's going to be part of adjusting how the product can be used, or sometimes even expand the functionality of your product. We kind of make fun of them sometimes, right? You hear about things like the guy who used his lawnmower to trim his hedges, turn it up on its side. And we also end up paying out the warranty claim regardless of what's happened to it. There might be evidence that it's been used in a way it shouldn't, but you still end up paying out the warranty claim. And some companies work hard to try to find ways to keep a record of what's occurred, right? Apple has an internal device that will change color if it's exposed to water so that they can determine and I guess effectively argue with you if they should be replacing it or not, because they say not to use it in water. But we all know where that's heading from a product development side. Somebody's gonna introduce phones that are more robust, can handle water, submersion, and then the game is on for everybody else to catch up. So you don't just want to address these issues by simply trying to track what's occurred. If this is occurring and an issue, eventually you want your products to include this functionality, and that's part of what Use Case 7 aims to do. So there's no court where you ever get to present your side of what has occurred. As I explained, Apple kind of tries to do that a little bit in other companies with those devices that record what has occurred. But at the end of the day, there is some of the customers always right. We want happy customers. We want customers who feel our product's robust and going to continue to serve them. The weird way to use it, that doesn't go very far. Typically, those come in, they get paid out, and then the team moves on. There's really not considered any internal fault, but it would be nice to find a way to learn something from those. What we ideally want is the bulletproof label. I imagine a lot of you have products that you've said are bulletproof. And this is usually because you've used it in ways where you expected it to fail and you wouldn't have held the manufacturer accountable, but yet it still worked and you were very impressed, and it created a lot of loyalty. A lot of loyalty that the company would have had to spend a lot of money with marketing and campaigns to get you to even begin to hold them, your opinion of them in that way. For me, one product I've had that I feel this way about is a DeWalt drill that I purchased. It wasn't a super expensive drill. It was kind of a middle range, something you get at Home Depot. And drills are, generally you don't want to get dirt inside of them. You don't want to get moisture inside them. In this drill, I got the worst thing possible inside of it, which is plaster dust. Plaster dust effectively is a grinding compound, so in something that's moving, it's a horrendous thing to have. And I was doing construction in a living room and bringing down a lot of horsehair plaster, old style plaster, so it actually was getting buried in it. And I was using it, blowing it out and using it, and it never actually ended up degrading the life of the drill. And this really surprised me, and I realized that the manufacturer must have actually put a lot of effort into seeing how it dealt with intrusion of dust and particles. And they probably did a lot of work with regard to airflow and where it went and how quickly it got out. And they probably also did some work with clearances. I imagine there's some clearances they might have opened up in certain areas to ensure that what gets in can also get back out. So they clearly had worked on this issue, even though me as a customer, I was not expecting the product to be able to handle that. So they clearly, and this is kind of what fed into me believing and working with my customers with this, is that by looking at the stress failure mode relationships, not just within the two extremes of does it satisfy the stresses that we've set as parameters, and then with Hall testing where you're looking to disassociate it but use the failures to drive design improvement, what about that range in between? What about continuing to push out the actual applied stresses and have it still be design input? So let's find a way to incorporate. Yep.
Do you happen to know that DeWalt is a Walmart customer? Oh,
are they?
Yeah.
Okay, well there you go. So that's how that happened then. They're on board. DeWalt's on board. Well, please send them my regards.
I sure will.
Okay, all right, thank you. So then, of course, with making more robust products, the question always is, what's the cost? How does this change our design cycle? How does this change the product cost itself? I mean, cost point can be, obviously a very strong point and difficult to negotiate, if it is especially with something like that drill where you're manufacturing in the thousands or tens of thousands of units. Even a couple pennies change has a large multiplying factor. So with the UC7 technique, in some cases it's almost free because, as I described in the example with the drill, they made design changes that effectively probably didn't add any cost, and it was simply by including this one technique within a broader program. So the motivation is a warranty. This can avoid lawsuits by, again, getting that margin to diminish the likelihood of the events occurring. Satisfaction, obviously, is a big deal. Brand value. Think about how we just spoke about a brand, right, from a specific model, but now the entire brand has taken on that credibility. So the benefit can be quite exponential with regard to perception. The design functionality, this now is going to be a product that they might even be able to advertise to be used in a broader context. This could be a product that you might actually be able to say in this case, or make small modifications to it. This was a product intended for non-intrusive dust and water environment, and they might be able to advertise that now actually you can take a higher class of even with the same design, so that's a broader market share. And then, of course, there's new products. What if investigating this inspired an entirely new product? There's lots of examples of manufacturers having a product, finding out that there is a greater need or that there is benefit for being used in a more expanded type of application, and actually has then inspired an entirely different product line, and that's occurred in just about every industry. So here's an opportunity that instead of waiting for the customer to use it in those ways, or to be sorting through failure data to find that inspiration to make that next level product, this is a way to find that information within the first generation of the product. So here's a couple of the areas where you're going to find it yields information. There is the initial, right? So the initial high load stress that can occur and will give you a failure response early on. But there's also the accumulated stress over life. So think of that example like with the dust again, where I probably would not have experienced an immediate failure, right, as it was exposed to dust, but I would have had a dramatically shortened life. So we're not just looking at the stresses as in an individual stress where you're looking for a response. Time can be the factor where we're looking to extend the period of time from failure from an accumulated stress. And it also can have a very big impact because the last part, that bathtub curve, the wear out part, you're effectively also creating margin on that and extending it out. Because with the wear out side, you don't want that tail coming in too close to the end of the product line. So if you push that out, less of the tail is potentially going to occur within the normal product life. So here's some examples that are personal to me. My dad used to load a lot of firewood in his Nissan Sentra. Now, he would have his brakes and shocks wear out and suspension faster than the average Nissan Sentra owner. For whatever reason, he chose not to purchase a truck. That is clearly use case 7. And how could that possibly be handled by the dealer, the designer? Are they able to prove it, even though they see little barks, pieces of bark in the back? So should this inspire them to make a type of car for people who don't want trucks that are more robust? Well, here we are many generations later, and we see a lot of these crossovers. And we see these different, you can think about many product lines where you see specific models, and you see ones that then begin to fill in the gaps where there is a need. So they found that there is a market for people who want smaller cars that can have a little bit more suspension travel for off-road, and also better cargo carrying capacity. And that effectively it's now a very dominant part of the automotive market, so much so that Ford has announced they're no longer going to make cars. Their entire product line is going to be crossovers, SUVs, and trucks. So my dad was ahead of the curve, I guess. The other is, total misuse. I have heard of people taking their parents' cars when they were younger and doing burnouts with them. And this is clearly use case 7. This is important to consider when you're taking your test cases and you're defining them that you're going to make your reliability statements on. If you were to design a vehicle, you would come up with some standard conditions. You'd say, okay, this is the characterization for the commuter. They do a lot of miles at a set speed, not a lot of acceleration and braking per mile. If you could have your city driver, right, this would be the person who does a lot of start-stops at lower speeds, a specific set of stresses. But are you taking into consideration the ones where that car that was obviously purchased by somebody differently who's driving it in this case, right? The car was purchased for use with, let's say in this case, a parent with younger kids, so you have the minivan, you can take everybody around, but the teenager also takes it out. And that's going to be pretty difficult to diagnose when the transmission blows and mom brings it in to be fixed. Because she's also unaware. So this is where, these are the surprise use cases that are actually truly occurring for the product, but without pursuing them in the development process, it's kind of unlikely that, or it's just a great deal of time to identify them even in the field, because it'd be very hard to decode what has actually happened. And then there's preventive maintenance, right? That's a stress. I actually remember when I was younger having cars that leaked oil. So the oil changes, we just called them automatic. As long as you keep filling the same amount that's draining out, the oil was changed. We never actually bothered to drain it entirely. So all that sludge was in there. Now, this is a customer, for a product which has a preventive maintenance cycle, and it's not being adhered to. So can the use case 7 idea of investigating specifically going beyond the margins of stress that are associated to actual use cases be helpful? Do we really ever investigate what happens with preventive maintenance programs that aren't done as intended? Because we tend to rely on that. In a lot of product design programs, we simply say, well, they're going to do preventive maintenance. That's going to take that part of the wear out for that subsystem and reset it every time. But are we really looking at what occurs as some people run that farther and farther out? And are we staying accountable for it? Because they don't work for us. If you're counting on the customer to do preventive maintenance, are they really accountable? So as I described, you have your use cases that you typically create, use case 1, 2, and 3. So as I gave the example with the automobile, use case 1 might be the mixed, the mixed driver who does some city driving, some suburban driving, a little bit of highway driving. And you're going to have stresses that you're going to apply to it. These may be, stresses of the exposure to start-stop, cycling, temperature, environment. It could be salt. And all of those are set at a certain parameter, and you say that's that use case. And you have to remember, any reliability statement we make, you go back to that definition, it's critical that you have a specific use case that you're making that statement on. Remember, the definition for reliability has no value without those three underlying components of how it's used, what environment, and for what period of time. So any reliability test we do that we make a statement on has to be based on a specific use case. So we work hard on getting those defined. So you have your first one, and then you have the second and a third case, and these might explore more extreme areas for some of the stresses. You would see all those different dots on those curves move, right? Because the city driver, per mile, the brakes are obviously, and the acceleration is obviously going to be a much higher accumulated stress than the highway driver. So how do we then, for the same customer, give them the same reliability promise with such a dramatically different use? We have to test the different use cases. So use case 7, the idea is that we create a use case that effectively doesn't exist. It would be very unlikely, it would have to be a race car driver to take all these things to the extreme, right? It would be an off-road race car driver to take them all to the top in the same use case. And that's why it's unique, is you are taking those combinations of stresses that usually you take some up and some down, and you're putting them all at levels that can really be done, but that are all high in combination. So now you're also getting that effective design of experiments of combined stresses and what can occur. So where does it fit into a program? So reliability tests, I made this a while back because I kept finding myself describing it this way verbally. And reliability tests, the objectives are to measure and improve reliability. So I created this line, one end's improve, one end's measure, and dropped some of the common tests on there. And so Halt testing, as you recall from the previous presentation, is very much about improving. Measuring, it doesn't do a lot for measuring. It's very hard to measure reliability from Halt testing, but it is amazing at improving. Accelerated life testing is very much about measuring, because accelerated life testing is looking just to, under a specific normal use case, what's the time to wear out, and it gives you something back that then you can do the statistics to determine that last part of the bathtub curve. Reliability growth testing, it's pretty much right in the middle. A good reliability growth program will both measure and improve reliability consistently throughout it. So, Halt and stress margin are the two that I was thinking about when we came up with use case 7, and realized it really fits right in between. So it allows us to measure performance under that specific extreme case, but it gives us a lot of improvement feedback very quick, much quicker than stress margin testing, which looks to specifically define those margins. So if we take Halt, stress margin testing, and use case 7, our real objective is to take the failure rate that occurs during normal use life and push it down. That's the first thing that we're trying to do. And if you recall in the previous discussion about Halt, I talked about how Halt, that's one of its objectives. So use case 7 is looking to continue that process and allow that blend between measuring and improving the performance with when you have high stresses, looking to see what those margins are. So it will also have the peripheral effect of helping with the quality side, because by default, any of those margins in normal use will also affect quality. And it will, of course, as I described, if you include in your use case using time for accumulated stress, you will as well improve wear out. So you do have opportunities to help the bathtub curve for the whole population through their entire life. But I will emphasize that it is the normal use period and the reliability during normal use life that I've seen gain the greatest benefit. So just to quickly, highly accelerated life test, which I've referred to as high accelerated limit test. The idea here is that extreme stress to ruggedize the product. right? But we're disconnecting from measurement. And that's part of what we're going to get is that extreme stress, but still going to the limit we can just before you disconnect from measurement with use case 7. So we can use a lot of the same Halt type stresses and techniques, but we can't allow them to just be incremented until we see failure. We have to keep them tied to use case. But you can see how Halt is a close cousin to use case 7. So with margins, the idea is that we're taking nominal values and pulling them as far apart as we can. So you have variability around a stress. If what we want to do is take the average value for your population, your design unit. You don't want to ever take your Superman unit and do this comparatively. So there was questions earlier about statistical significance, right, with Halt. And I said, well, statistical significance is not directly applicable because we've disconnected from the use and we're just taking the stresses till we see the response. And the response to an extreme stress should be somewhat similar product to product. So we're less concerned with sample size. But here, with use case 7, we are keeping that connection, so we do want to have higher sample sizes than we do with Halt testing. And that's for the simple reason that there is going to be a distribution. And if we do end up testing with the Superman unit, we're not going to find out the true relationship between the stresses and the performance of the general population. So I know in Halt testing we looked at this, but for people who are just attending the use case 7 part discussion, those variabilities, if the center part here with the operating specifications is how the unit is intended to be used, and the upper and lower limits are where the performance begins to drop off. And so our margins are between those two. The green body represents the entire population. And the overlap with the upper and lower limits is going to be your percentage of failure. So if we're able to identify now specifically the relationship between use stresses and incrementing them up in performance, and we can change the design through this, we're going to move the two means of those distributions farther apart. And now we have a much smaller percentage of overlap between the distributions. So that's just like Halt, right? That's what we found after Halt, and that's what we're going to find after use case 7. But we're able to make statements on it with use case 7. That's the big difference. So there's always, with new testing principles, and use case 7 is new, the emotional acceptance, right? And I talked a little bit about the emotional acceptance of Halt, right? So people don't want to hear their baby's ugly. You know, you're putting high stresses on it. You're going to induce failures, and there's a very strong resistance. And then as they participate in it, they tend to have this euphoria of getting to see something they didn't expect, and being able to incorporate that, because if they're a design engineer, right away they're thinking how to improve the design to have that not happen, and that's the value. So they take their great idea, and then next time they have a new design, they're the first ones coming back and wanting to do Halt because they got that great feedback. So use case 7 tends to follow a somewhat parallel type of process of emotional acceptance as I've introduced it in the programs. So the first is, well, yeah, it can be used that way, but it's not our fault. We told them not to use it that way. And then somebody says, well, actually, I've seen my wife do it, and I'm using that one specifically because someone actually said that. A design engineer actually said that with a family appliance. And we were talking about and defining use cases to make reliability statements on. And we started talking about ones that were like, okay, what could you do that's ridiculous with this and that? And then somebody was like, actually, do you know what? When we were bringing these things home, my wife actually did that. You know, we realized, like, okay, see, that's, you know, what is it, the luck that we had somebody that could make a personal reference to it here. If they can, think about blowing that out to the big population. And then you have the third stage, which is, then we thought about, oh, that gives me a great idea. I know how we can improve it so it can sustain that stress. And then the fourth stage is when that begins to spread within the company. And in that specific project I'm talking about, after we were done, I ended up with an internal advocate who would go around to other departments and tell them this story about how we used use case 7, and it helped them identify issues in advance that customers could have done that previously they would have never considered to be valid use cases to make reliability statements on. But now they had, and they'd done it in the first generation. So I just want to go back again to the definition of reliability because of how important it is. So if you had, let's say, a plastic fork, and you advertised that had a 99.999% reliability without indicating the true use case, is that an empty statement? And it is, of course. Of course there's the implication, and we hear in advertisements reliability, and they give us percentages. But they don't tell us what they're making that reliability statement for. So with a plastic fork, there's kind of this implied, oh, you're going to use it indoors and normal temperatures, whatever you consider normal to be, for eating food. But what if the fork was used in a mountain camping trip, right? Is the manufacturer accountable for a plastic fork that breaks when it's under extremely cold temperatures? What if the back end of it's used to pry something open and it's not just used for eating, right? Are they accountable? So that's where if you were on this team and you were to create your use cases, remember I showed those 3 use cases which in the distribution, I don't think any of them would include using the back end of the fork at extremely cold temperatures somewhere. But if you were on that team and you were asked to do this exercise, would you think about something like that? I bet you somebody would mention something like that. And then you can choose how to mitigate it. You don't have to make a fork that can survive that. It could end up being just simply a warning or a statement saying our reliability statement doesn't account for that, or don't use it this way, it could be dangerous. It doesn't have to be design change. You can mitigate the negative impacts in other ways. You also might realize that there's a plastic fork you can make that has threads in it, right, that then give it more of a composite kind of structure, and that's your rugged, outdoor that you sell at, Eastern Mountain Sports as a different type of utensil because you stopped and thought about it and you beat everybody else to the market with that. So when creating use cases, which is a very important part of a design program and a reliability program, I typically start with 3. Select some key categories for this, like with the car example, you heard me say like amount of braking and acceleration, miles, per whatever time period, environmental conditions. List these out and get them all out there. You don't have to use all of them for all the use cases, but let's just kind of in that brainstorming methodology get all the use case categories out there so that you're fully defining each use case. It's unfortunate when you create use cases with categories and then come up with other ones that you add categories to, and now you have to go back to the first ones and decide what those levels would be, as opposed to doing it in the order of creating the categories first. So I'll begin to start off by summarizing the typical customer profiles. That kind of helps create the foundation. Then if you can find any historical information, that can kind of help you on the path of extracting these unusual uses, because they're out there. And people are more creative than you are probably, because you're picturing how your product should be used, and nobody's ever read a manual. Everybody uses it the way they want to. So, and then begin to create your composite cases, right? So you've created your first few regular cases. Now begin to mix cases together, right? So I always call this the midlife crisis use case, because the best example I came up with is I was talking about the cars and the way they were used, and you have the little lady that drives it, you have the family mother or father who takes the kids around, you have the commuter. But what about the guy having a midlife crisis, right? He's not the kid doing burnouts all the time, but he finally bought that Mustang he always wanted, and 90% of the time he drives it to work. He does drop the kids off every so often, but on Friday nights when he gets with his buddies, he still does burnouts and pretends he's 18. So that's a composite use case where you kind of try to combine some of the other use cases to find a combination of stresses that might be unusual. Yeah?
So can we define like a calculation of a use case based on like DOE?
So the question is, can you find a calculation of a use case based on a design of experiments?
Yeah, based on like design, same methodology for design experiment, like having stress 1, 2, 3, etc.
Absolutely. Oh yeah, absolutely. This ties directly into that as well, because with use case 7, you're also might find combinations of stresses that cause results that you wouldn't have otherwise. Because as I'm describing, if you originally just broke down that car thing with the kid doing burnouts, not doing oil changes, the little old lady, the commuter, the city driver, there's going to be some combinations there you're not going to consider, where with the design of experiments, if you had identified 3 types of stresses, categories as the highest, and combined them, it's exactly the same principle. You might find a result that would not have occurred otherwise. So why did I pick 7? Well, we always pick 3 use cases as a start. And then we do 4, 5, and 6 when we're like, okay, this is kind of some of the traditional unusual ways, right? What about the guy who buys your lawnmower but has a lot of big roots? And so every so often the blade, you get that torque spike through the system when it hits a root. I mean, it's not everybody, but there's some that are like that, and that's still within the normal expected use that the design should consider. So the 1, 2, and 3 are usually kind of a low, medium, high. The 4, 5, and 6, we tend to try to find very specific factors from examples that we know. So 7, you got the guy who uses the lawnmower to trim the hedges, right? There was nobody in the design program that thought about that. But do we care? Do we care about him? Do we care about the fact that he has a problem with the carburetor because it's sideways and the fuel doesn't stay in the bowl? Does that matter to us? Well, maybe it should. Wait a minute. There's people who use mowers on very steep gradients. What if we took that in consideration? What if we were the brand that nobody had the gas starvation with? Because we stopped and thought about use case 7 with the first generation mower before we went to the second. We just satisfied a market that traditionally had issues. Well, what if we actually then fully made a product that really addressed this and became a specialty product for this, for driving at a really high sideways angle? And we took other stresses and issues with it. For instance, that guy's looked like it's about to roll over and kill him. He has no roll bar, and his back is clearly going to hurt the next day leaning on the side. What if we actually took this idea that originally we thought was silly and began to evolve a product to satisfy it? Did we just, create a whole new market or satisfy a market that was there and nobody thought of? What if this now leads us to something to where now there's other technologies available that nobody's thought of applying to our product, and it inspires us to apply it? People don't think about autonomous lawnmowers a lot, and the value's not there, and probably the cost point doesn't work. But what about people that on an industrial scale have to do a lot of, very rough terrain, not their yards, but think about the sides of highways, right? There's a lot of actual, facilities that have to maintain rather unusual grounds. Well, they are at a higher cost point. So what if all of a sudden we take all this autonomous technology and apply it to our product before anybody else does? And now we've created an entirely different product line, all because we started thinking about that guy. And that can happen with use case 7 too. You can beat everybody to market with an entirely new product just because you thought about some of the unusual uses and stresses that could drive issues with the current design. You could end up with this. Any questions?